Here is the integral to find the arc length of a polar curve. We have a similar integral to find the arc length of a parametric curve. The arc length is S is equals to integral from alpha to beta, the square root of the polar equation square plus the derivative square. Okay, this is a r square. R is just the polar equation. So I give you a polar equation, you sketch the graph, and then this graph, you will need to find the arc length of this graph. And then this graph goes from 0 to 2 pi. And then the length of the graph of r equals to f of theta from alpha to beta is this integral. So you have a polar equation, you need to square the equation, and then you find the derivative. You also square the derivative, you plug in, and then you integrate. I will say the hardest part can be the square root. The hardest part maybe comes from the square root. Okay, let's do it. I have 2 minus 2 cosine theta, and then that is the graph. I will square that, so that is 2 minus 2 cosine theta square, which is 2 minus cosine, forgot the 2, 2 cosine theta times itself, 2 cosine theta, and then 2 times 2, let's move this up, 2 times 2 is 4, and then minus 4, we have a minus 8 cosine theta, and then plus 4 cosine square theta. That is the square. Okay, so we got the first piece done, and then we need to take the derivative. Okay, let's put the derivative right here. I will do a r prime, which is the derivative of r with respect to theta. The derivative of 2 is 0. The derivative of cosine is negative sign, then plus 2 sine theta, and then you square that, dr d theta square, that is equals to 2 times 2 is 4, and then sine square. When you add them, I see something that really good, because I see a cosine square plus a sine square. So that may be helpful. And then here is the arc length, that is equals to integral from 0 to 2 pi. Okay, here is one thing that you may need to pay attention to when you study for this topic, is the 0 to 2 pi. What if this is not given? When you sketch the graph, how do you know that completing one graph is from 2 to 2 pi? That is not always 2 to 2 pi. Sometimes that is a 0 to pi. So what you have to do is, you can use decimal if that is allowed. You in your decimal, you input r equals to 2 minus 2 cosine theta, and then you go to the next line. The next line, you graph the same polar equation one more time, but you change this to a different color. And then you will see that after you graph a polar equation, underneath that polar equation, they ask you to specify that theta is from where to where. The first one, you can say the theta is from 0 to 2 pi. No question with that, because you see the graph, maybe the system displays from 0 to 2 pi, that is good, or 0 to pi. And then in the second line, I want you to go from 0. Let's change that to a pi over 6. And then you change from 0 to pi over 6. You can see that from 0 to pi over 6, this piece is actual, then one piece of the graph will be shown. And then you change that to a 2, change that to a 3, to a 4, to a 5, to a 6. And then if one full graph is 0 to 2 pi, as soon as you reach to 12 pi over 6, you will see the entire graph. You will see the entire graph. So the idea is, we go up the pi over 6, the increment is pi over 6, we go one step at a time, and then we see how the graph is traced. So maybe you will see that from 0 sometimes, not in this one, 0 to pi, that is already one graph. So this one is 0 to 2 pi, and then they gave you a 0 to 2 pi. That means one full graph must be from 0 to 2 pi. Sometimes they may leave these questions to you. Hey, for one full graph, that is from 0 to where? That is what you have to find out. Okay. And then I will draw a square root. R square. R square is 4 minus 8 cosine theta plus 4 cosine square theta, and then add the derivative square, that is a plus 4 sine square theta, and then you have a d theta. Okay, and then we can do some work in here. So this one you can factor out a 4, and then you have a cosine square plus sine square. Cosine square plus sine square, that is a 4 times 1 equals to 4. And then these 4 and these 4, you can do a 4 plus 4, that is equals to 8. So that should simplify a lot. And then s is equals to integral from 0 to 2 pi. I have a square root 4 plus 4, that is 8. I have an 8, and then minus 8 cosine theta. 8 minus 8 cosine theta. The square root is in there. I cannot just integrate one term at a time. How about I will factor out an 8 from 0 to 2 pi. I will just factor out an 8. Then this is a 1 minus cosine theta. And then the square root of 8, I can take it out. This is the square root of 8. Integral from 0 to 2 pi. I have the square root of 1 minus cosine theta. And then d theta. I forgot the d theta right there. And then there. The d theta. Okay. How you can integrate one term at a time because of the square root. When you study some problems in this topic, can you study this formula? You learned this before, half angle formula. Half angle formula, that is sine half of theta is equals to plus or minus. The plus or minus is part of the formula. Square root 1 minus cosine divided by 2. But I don't have a divided by 2 in my integral. So how about this? I will just square both sides to eliminate the square root. So that eliminates the plus or minus as well. Because positive and negative, when you square that, that is guaranteed positive. And then I have a sine square. Let's do a 1/2 theta. I feel more comfortable with that. And then this is a 1 minus cosine theta divided by 2. How about we multiply the 2 to the other side? Then we get 2 times sine square 1/2 theta equals to 1 minus cosine theta. And then we can bring this over here. So this is 1 minus cosine, right? 1 minus cosine is the yellow piece. And then I will put it right there. I will put it right there. Okay, and then back to the integral. I have square root of 8. Integral from 0 to 2 pi, a square root. And then a d theta. What do we have? We have 2 sine square 1/2 theta. Okay, we can take the square root of 2, and then this is square root of 8 times square root of 2 from 0 to 2 pi, the square root of sine square, and then 1/2 theta, d theta. The square root and the square got cancelled, and then this is square root 16. And then integral from 0 to 2 pi, 0 to 2 pi, and then I have a sine, and then a 1/2 theta. Okay, so now we can integrate this. And then square root of 16, that is equals to 4. The integral of sine is negative cosine. Negative cosine half theta. Okay, when you take the derivative of cosine half theta, by chain rule, there is a 1/2, right? This one by chain rule. There is a 1/2. Then we need to prepare a 2 in front of it to get rid of the 1/2 because there is no 1/2 right there. Okay, now 4 times negative 2 is negative 8. So we have a negative 8. Can we have a negative 8 and then a cosine? Okay, I can even factor out a negative 8. I can just do a cosine pi minus cosine 0. Cosine pi is, this is a negative 1 minus cosine 0 is 1. 1 minus negative 1 is negative 2. Negative 2 times negative 8. The arc length is 16. So that is 16. And then this represents arc length. Arc length of what? Arc length of this this polar equation. So the length right here, this length is 16. this graph comes from this polar equation. You have an equation, you sketch the graph, and then the length is equals to 16. All right, so that is the end of this problem. I will say the hardest part is the integration. So when you study for this topic and then the integration, be aware that you have to bring this formula back. Okay, then if you don't remember the half angle, double angle, power reducing formula, sum to product, product to sum, then you have to look it up, because on the exam, you may see a problem that requires this to continue the integration. Okay, so that is the end of this video. If this is something that you would like to see, click the like, click the subscribe, and I will meet you all in the next video.